For our project, we decided to do sand casting. We originally created a design in AutoCAD, and we extruded it and sent it to the Dremel Digilab and 3D printed it in the UGA Engineering Lab. And this is our design. We were trying to make the UGA Arches logo as it is appropriate, as we will graduate soon. Then we cut it in half and put it in a 2x4 frame and packed sand around it to get a nice good seal, so that when we flipped it over and extracted the logo, there would be a nice fine object mold that we could pour our metal into. This is the process of how that is done. We needed to make sure we really got it packed in so that the mold would not crumble as we extracted the mold. Upon finishing, we scraped the top layer off and made sure it was flat to the ground so that when we flipped it, there would be no uneven surface. That is the finished packed molding before we flipped it, and that is after we flipped it. As you can see, the mold, we have to extract that 3D print from the mold, and it would leave a mold for us to pour the metal into. And we were originally going to melt aluminum foil over a typical fire, as the melting point of aluminum foil is 660 degrees Celsius, and the campfires are usually around 1,000 degrees Celsius. However, it did not work, and we also tried to put it over a gas propane tank, but it also would not melt the aluminum. So we decided to switch to melting lead in a blowtorch, and this is the process of how that was melted. As you can see, the bottom is getting hot enough to where the lead was starting to melt, and as a result, it will melt the bottom and all the top will come crashing down and eventually melt the whole. For this, we bought some lead sinkers from the local fishing store and used them to melt down, but unfortunately they had some steel hooks in them, so after completely melting the thing, we will have to scrape the excess metal that is not lead off of it and put that away so that we have a pure lead substance to pour. This is us extracting those steel tips and scraping off anything that is not pure lead.
It's already on camera.
This is our mold that we are about to pour in. We have to initially pour in a drainage hole so that we are not pouring directly on the mold, as it causes a disruption in the surface. We poured excess to allow the cooling shrinkage to occur. After officially hardening, we washed it off with a water hose and had to begin the process of fine-tuning it to make it look better. We clamped it down and then had to cut off the excess metal from the pour hole. We began the grinding process by using an electric-powered grinder to cut off the excess hole, the pour hole. And I could show the whole process, but it would take couple 30 minutes to 45 minutes to grind all this off and get the hand grinders and grind it out the arch logo and grind the holes to make it look more like arch. As we realized that when we extract the mold piece from the mold, it crumbled, the sand crumbled a little bit, establishing rough edges, and effectively made us have to use more grinding and more polishing to make the final product. As you can see, this is our finished product on the mold side. And this is our finished product on the pouring side that was in contact with the sand. Things we could have done better is obviously made the molding sand more compact and have a better mold spot for us to pour the metal, as well as we learned several things that the melting temperature of aluminum is hard to reach in a typical campfire as well as a typical propane, and things we had to use a lower melting point of metal. However, we are happy with the final product, as it is a little rough around the edges, but it still maintains a general shape of the UGA arches. And we replaced the real arches with this. Nobody would ever be able to tell it was different.